In this video, we're going to explore different kinds of properties of logs. It's still Learning Target 1, which I can use and apply properties of logs. In our last video, we went over more about using logs. Today, we're going to talk about applying properties of logs. Let's explore these two problems, log base 4 of 64 and log base 4 of negative 64. In the first problem, this answer is real. It's real because the log is asking us 4 to the what power equals 64. That question mark would be a 3. So I come up with an actual answer, a real answer. So log base 4 of a 64 comes out to a normal number. When I try to use log base 4 of negative 64, I'm asking myself 4 to the what power equals negative 64. Because I'm starting with a positive 4, it doesn't matter what power I try to use, a 1, a 2, a 3, a 4, doesn't matter. Any exponent I apply to a positive 4 is going to come out to a positive answer. So there is no possible way for us to actually come up with an answer for the question mark. And because of that, this is impossible. It's not real. There is no number that can go here, okay? It's not real. So don't ever try to do a log to a negative number. Our first main property of logs is the product property. It's a way of rewriting logs, and this is a two-direction street. I can change one side into the other and the other side into the other. Log base b of m times n, because this is multiply, which is what product means, I can rewrite this as two logs. So right now it's written as one log. You can transform it into something that says log twice. Notice that it said multiply, so I put plus. This is exactly like our exponent product property, which states that if you have two same bases with exponents, you would add those exponents, right? 2 plus 3, x to the 5th. This is the same thing. It says m times n, so I put plus. So let's use this property to rewrite log base 3 of 125 times x. So let's expand it. Both of the logs are base 3. It says times in between them, so I put plus. The first one gets 125 and the second one gets x. So I've expanded it from saying log only once to saying log twice. I can also work the other direction and do what's called condensing, to smash two logs together to say log only once. Since it's a base 2 on both these logs, my answer will be a base 2. And I take 4 and I multiply it to 10 because of the plus sign. So my final answer is log base 2 of 40. Our second property is quotient property. Remember that when you have two bases the same, but with division in between them, you take their exponents and you subtract them. X to the 1 power. Much is the same way with a log's quotient property. If you have log base of something and its of is a number divided by a number or a variable divided by a variable, we can separate this from saying log only once into saying log twice by, instead of putting division, we put minus, because of the same property that controls subtracting exponents when we see division between the terms. So let's use this property to expand log base 9 of 81 divided by x. I'll write log with a base 9 two times. It is a minus sign in between them because it says division. The first log gets 81 because 81 was on top, so it comes first. The second log gets the x because it comes second and the x is on bottom. Let's work backwards and combine these two logs to say log once. What's the base on the log? It's 4 because that's the base on both of the logs. It says minus, so I'm going to have a division for my single log. The x comes with the first log, so it goes on top. The y is with the second log, so it goes on bottom. Our last property is called the power property. It's probably the most easiest property to use when you're dealing with logs. It states that log base b of m to the x power is equal to the same thing as x times log base b of m. Basically, we can move the x to the front or put it back up on top using the power property. Do know that log base b of m to the x power is considered to be the condensed version, and with the x in front is considered to be the expanded version. So let's expand log base 2 of 32 to the 3y power. That 3y exponent is going to get moved to the front to say 3y times log base 2 of 32. Notice that 32 does not travel with the exponent. Let's condense 9 times log base 2 of x and make this number in front of the log travel back and be an exponent for the x. Log base 2 of x now has a power of 9. You're going to be expected to use multiple properties at once to combine multiple logs. So we're going to have to first look through and evaluate what is happening and which properties we could use. Here's the properties I see. I see a plus sign. That means there's going to be a product property. I see a 6 in front and a 2 in front of these logs, so there's going to be power property. And I see a minus sign, so that means I'm going to use quotient property. First, let's rewrite this with the power property. Log base 4 of z plus log base 4 of x now has a power of 6 minus log base 4 of y to the power of 2. Now I can combine from left to right using my properties. I have a plus sign, so let's combine these logs. Log base 4 of z times x to the 6th power. And now let's use quotient property with the minus sign to combine these into a division sign. Z times x to the 6th is on top, y to the 2nd is on bottom. And I've condensed this all the way down into a log that only says log once. That's what condensing means. Let's take this log and expand it into as many logs as we can. First off, if I want to get to any of this information on the inside, I'm going to have to use power property on this exponent. Also, there's going to be another power property as well with the 3. And since there is a division sign, I will be using quotient property as well. Let's take the 2 and move it to the front first. So now my problem says 2 log base 2 of a over b to the 3rd power. Now let's use quotient property and expand this out into 2 different logs. A comes first, then the minus sign. Now do know, since I'm expanding this into 2 different logs, I need to make sure I have the 2 with both of my logs, because it started in front of this log that's getting broken into 2 logs, so they both have the 2. And I still have a 3 that I can bring into the front as well. And notice that since the 3 travels into the front of the log because of power property, there is a multiply here. So I'm going to multiply that into a 6. Is this the only way to do this problem? No. There are other methods and other orders that will result in the exact same answer. That covers our different properties as well as working with negatives. Make sure you answer the questions after the video. If you have questions, you write them down in your notebook and share them when you come into class. And don't forget to hit the submit button so I have record of you watching the video.